Okay, welcome everyone to my JavaScript tutorial. Today we're going to talk about a funny deciphering tool called ROT13, and it's it's easy to explain. It's difficult to decipher. It's easy to decipher. It's difficult to create something that deciphers it. All right, instead of going on forever describing myself, let me just show you. We have here a garbled mess of characters. All right, it doesn't say anything. Okay. Um, Believe it or not, this is actually what's called Caesar. I think it's Caesar's cipher. It's when you have the letters of the alphabet and you shift any letter 13 spaces. This is what you get. I'll show you what I mean. This is called a ROT13 table. So, okay, the deciphering is if you had the letter A and you shifted it 13 spaces to the right, you get the letter N. If you had H, you get the letter U. If you had E, you get the letter R. So if I gave you URYYB, then you would get hello, because each of these letters shifted 13 spaces to the right spells the word hello. Okay? So given these characters, we have to create a function that would decipher these letters to create whatever the hidden message is. And we're going to call that function ROT13. So let's get to it. Let's create a function for ROT13, and we're going to pass a string through it, and then let's return the string, and that should do it. So from here, we have to work our magic. Well, all right. First thing we know we got to do is we're going to loop through these characters in the string and modify them as we go through it. So let's start by creating a for loop. Let's set up the index and do what we almost always do. Check the condition and then increment it up, and then we'll just console. We know how to console log string. Okay, we know how to console log the string index, right? That gets us all the letters one at a time, spit back at us. We know how to get the numerical index, just the numbers, okay, the 0 index, 1, 2, 3, 4, 0 counting. But this doesn't do us much good, does it? Because this doesn't correspond to the character, to the letter in the string. It just corresponds to the index. So there's a method we can use that actually corresponds to a numerical value for these characters called Unicode, or it's called an Ascii table. I'll show you real quick. This is a big old table here. All the characters we can think of, including ones that aren't even invented yet, apparently. So starting with like special characters, they're all assigned a number on this Ascii table. Okay, so space gets number 32. Exclamation point gets number 33. If we go up to our capital letters, we're just going to deal with capital letters for now. We're not going to deal with lowercase. But big A gets 65, and it goes all the way up to big Z gets 90. Okay, I don't want to go too far into this. I'm just going to show you. I've actually put them all into a notepad table here so we can look at it. If we're going to be shifting left to right, we'll tell what the characters are. So, okay, how do we return then, given that, the ASCII values for these big letters? Well, there's a method called charCodeAt, and I'll show you. charCodeAt, and then we just give it the index of that string, and boom, we have all these funny looking numbers here, starting with 76. So as you can see, 76 is L. We started with L, 76. 66 is B. We had B next. It gave us 66. It gave us B. Okay. So we know what this is doing, and we can actually, let's just store this somewhere for now. So we have, we'll just give it a variable. We'll call it number. We'll start at 0. And so all these good numbers, we'll just keep this in variable number. And for our purposes, as we go through this and kind of break it down, let's just keep these characters handy. We'll comment them out so we can just see them. We know that these characters, they spell these numbers in ASCII. Okay, so all right, we got them stored here in the number, but all right, what do we do with it? We know that when we get these numbers, if we add 13 to it, if we shift them 13 spaces to the right, 76 then becomes what? 76 would become something. I think something up here. What's 76 plus 13 is 89. So it would become Y. Y is the first letter. Okay. But so okay. I mean, we can't just return the string. Let's just create a new string where we can store all this stuff at, and we'll keep it empty for now. and then let's return the new string. So we'll keep it empty. So okay, if we have the values of the ASCII values of these capital letters, how do we then take that number and then convert it into a character? Because we want to return characters, we don't want to return numbers, right? If we return numbers, then we can't read anything. So there's another method I want to introduce to you called from char code. And how this works is if you have the new string, let's just keep this. We'll call it new string. And then if we take this method and we say string dot from char code, and then we give it a number, say like 65, would spit back that letter for us because 65 equals A, right? So any number I put in here is going to return that value. 65 equals B. 65, 66 equals C. 67 equals C. I know I'm stupid. Okay, well this is good, I guess. What if we pass the number through here like this? Let me get the last character in this string because obviously it's going to hit the end of the condition here and then spit back out of exit the for loop, and then it's going to reassign the new string to whatever the last character was, because that's what number is going to be, and then it's going to return that new string, which is just one character. So that doesn't do us any good. We can't assign it to it. What if we kept it in the for loop, and then instead of just assigning it, we added it to it every time it got there? Okay, now we're right back to where we started. But this is actually pretty good. We spit back the same characters, okay? But all we have to do now, we know what these characters each stand for. These numbers along the way are going to get stored in the number variable here. So things are going somewhere. It's just returning for us the same characters because we're not modifying it at all. But the good news is we know that these numbers are going right up in here. So when we have this number, that's what is coming back out, and that's what's spitting it out of it. So all we got to do now is just tell it to do things if the number is higher or lower than, well, we have to just add 13. We got to shift it 13 spaces to the right. Okay, let's just break it down bit by bit. So if number is greater than or equal to 65, okay, we want to change number equals number plus 13. What happens then? Okay, we're getting close here. We got the word U out of this, but then we get a bunch of crazy stuff. I mean, look, if we go back to the Ascii table and we have special characters like I can't even find it. It's not even in here. But yeah, here we go. See, this is 94. We're getting over 90 now. Okay, once we get past 90, we get these weird characters. And the thing is, some of these letters are too far to the right for us to stay within the range of 65 and 90. See? So if we have Q, and then we add 13 to Q, well, we're going to be way past 90. So we could create a range, but the thing is, if we're past 90, we don't want to add 13 to it anymore. We want to go back down, don't we? So let's not create a range. Let's just say that if the number is greater than 90, then we go number equals number minus 13, right? Because we don't want to go all the way down. Okay, we're almost there. These just went back to where they were. So if it's greater than 90, it goes up 13 and then goes back down 13. We don't want to do that. We want to keep going down. So not 13. We want to double this. We're going to go 13 to 26. And you did it. That's it. That's all there is to it. That's how you decipher these codes. Okay, you can test it with new weird things and see how it works for you. But that's basically how you would write a function to decipher this funny looking string. Okay, thank you so much.